All right, so today we are discussing what compounding continuously is and how it is a different formula. How's that? So same as usual, P is the initial amount, A of T is the ending amount. The rate is inserted as a decimal, so it's positive for increasing, and it is negative for decreasing. Now, we've always done this in all of our formulas, but just making absolutely sure that you recognize that, because the R is in a different spot. The R is actually in the exponent. So that rate is in the exponent, so it's very important that you make it positive or negative. So that's actually going to, flip the graph and make it negative, make it decreasing. T is the number of years as per the usual. Now this E is different, but we do know what E is. We've used it before. What it is deep, but if you use this formula, 1 plus 1 over n to the nt, as your n gets bigger and bigger and bigger, the number that you get here, this number right here, approaches this. Okay, so it's just basically as you are compounding it more and more and more, it's getting really, really close to that number, in case you wanted to know. So compounded continuously, this interest is a good thing, but again, it's not as great as we want it to be. So compounded interest means that your principal is constantly earning interest, and the interest keeps earning the interest on the interest earned. It is, but again, wish we were making more money doing that, but it's not as great, but it's still more than nothing. Okay, so here we go. Nick invests $500 at a bank offering 7.5% compounded continuously. So with compounded continuously, we use what we call our PERT formula up here. That's our PERT, because it spells out PERT if you read it. So A of T is equal to 500. That's your initial investment. Now E is always here. E is the base for the next piece, which is the exponent. That 500 is not in the base. So E is the base. Okay, and then the exponent is this rate. So when you're at a bank and you're earning interest, that rate is positive. So you take that, divide it by 100, so you get 0.075. And then T is the number of years, so we multiply this times 5, because we're talking 5 years here. So put this in your calculator, and you get $727.495, blah, blah. So they said to the nearest dollar, so $727. Okay, which, after 5 years, you just earned, 230 approximately more dollars. It's pretty good for not doing anything. So there we go. Determine how long it would take for him to triple his initial investment. So his initial investment was $500. How long would it take to multiply that by 3? That's what triple means. So that means that's our ending value. That goes over here. And then we write our formula in. Remember, E is a number, so keep writing it. And now we solve it. So this is where, if you're solving for an exponent, you need to use logs. That's the only way we can get anything out of an exponent, any variable. So divide by 500. And notice here, this is 3. Because we tripled our investment, this is 3. Always. It's just the way it is. Okay? So now, so if you use the right amount, if you get that 3, or if it was double, you would get a 2 there. All right. So now, when we're writing this out, when we're solving this, this is the base, so it's log base E. So you remember log base E is ln, just it's the same thing, of 3 equals 0.075t. Then we divide by 0.075. 0.075, and we get our number. It was 14.6481, blah, blah, blah. So how long? About 14.6 years. They didn't say how long, but always look, come back up here, see what did I have to round it to, and if it doesn't say, you should write it all out, but this is just my fault, so there's that. Okay, have a great day. Remember, when you're doing decreasing, it's a negative rate, and that's it. Try or now you try, and have a good day.